All right. Hi, everyone. We're excited to be here. We love this space, by the way. Dewan, great job with the new lab. So we're Slicelab, and we're pretty excited to show you a few projects today. But before we get into it, we want to make sure we kind of give you the full story of how we got here. We're a design studio. We specialize in computational design and additive manufacturing, but we're really design heavy up front. So got a nice little goofy picture of us here so you can recognize us both when you walk around. So we both went to architecture school. We started at Carnegie Mellon to get our bachelor's, and we went into Penn Design afterwards to get our master's. And throughout that time, we started to hang out and realize that we had pretty much only one thing in common, and everything else was very not in common. And that's actually a great dynamic that we've used throughout the years. That one thing is what we're doing now, which is design for additive and all sorts of nerdy stuff that you guys are obviously here for. So basically, a year after we graduated, we founded Slicelab to just basically keep on doing what we were doing in school, as we realized that it wasn't that easy to do whatever we wanted once we started getting a job. You kind of had to do what they wanted you to do. So in architecture school, toward the end of our time there, we really focused on making wild different architecture forms and using different sculptural technologies and softwares, and started a little bit with scripting and Grasshopper, and it was really exciting to basically see what we can do with the software. And we got really into digital fabrication. We were both shop monitors and fab lab managers and stuff, and we couldn't wait to get into the real world and do this stuff. But obviously right away, at the time that we graduated, those opportunities weren't as present. We did get some cool projects under our belt at first. The second we graduated from Penn, Arthur went to Paris, I moved to San Francisco, and we started working on some architecture, and we did leverage some of those things we learned. So on the left you see Adobe Illustrator, if anyone remembers Scriptographer. It's a throwback for sure. It's basically a patterning plugin that goes into Adobe Illustrator, and mixed with AutoCAD, Arthur was able to basically make some really cool facade systems that were plasma cut and painted green. And on my side, I was basically continuing the Rhino and Grasshopper, but really starting to learn Revit at a corporate level, and understanding the very subtle facade systems that were, of this case, like basically stones and different types of masonry. So it was really exciting to start to leverage this stuff outside of school. So in 2012, we launched Slicelab, like I mentioned. We launched it remotely from San Francisco and Paris. There was a 9-hour difference, and the 9-hour difference at first was something that we had to kind of work through, but then we realized it was quite an advantage, not a disadvantage, because it allowed us to kind of work around the clock. So, if I was done with something, I would pass it on to him, he would continue it, and round we went. Obviously, seeing each other was very rare at the time. We have also entirely worked remote since then. We have never lived in the same city since we started the company, so it was really fascinating. During COVID, it actually not much has changed in terms of our workflow. Obviously, clientele and everything was a little different, but so we've worked between New York, California, Colorado, and Massachusetts. So starting off, the printers that we wanted to be using were not very big, so we would not have access to that kind of stuff. So I don't even want to admit how much we paid for this Ultimaker that we had to assemble ourselves, and that was really challenging to use. But that was the first printer that we had. We thought we were going to build out a whole lab and do this whole thing, but we quickly realized that this was not going to be the path if we wanted to be successful, and we would want to focus more on the actual design and let other people kind of print stuff, even though it was really helpful and intuitive to design the stuff, see it printed right in your space. We started with jewelry. Jewelry was something that was really translatable to what we learned in school, and it was something that we could obviously print relatively quickly and learn from it. And at the time, it was kind of in the industry. People were starting to do it a little bit. We initially were inspired by the architecture, like I mentioned, that we came from. So we took those structures we found very similar to the designs we wanted to use, and kind of like extrapolated the principles and tried to make jewelry out of it. We started relatively simple at first, like I showed you, with FDM prints. Then we got into metal and casting, and also chainmail-like lattices and stuff that kind of resembled this kind of stuff. So we really got interested in that, and that's when Autodesk basically said, why don't you guys come to Pier 9 and work in San Francisco and design some jewelry with all the state-of-the-art stuff we have here in the lab and all the software that you can use, and see what you can do. They specifically wanted us to work with the printer that they were about to launch very shortly after our time there. So at the time, we kind of created a few lines of jewelry. They were all inspired by suspended weightlessness that you see in marine life. So just like that elegant time frame where something is just floating in time, you take it out of water, it looks really different. We were really fascinated by that. This is one of the lines of jewelry. So this is when we started using hair systems in Maya, which is basically like a curve attractor, computational software plugin. It's actually built in now, but and it was something where we started to understand like a workflow of how we would take our thought process and how do we actually make the geometry and have control over the geometry, not just make a single one-off piece. But what was really exciting and was a pivotal point in our time with Slicelab, and this was about 3 years in, is that we were part of the lab. So we were able to, Arthur was flying from New York every 2 weeks, and we were able to be inside the lab, both testing this Ember, this is, RIP, it's gone now, but and their Spark platform, which is you see on the phone here. And it was really fascinating to be able to basically change stuff on your phone, send it to print, go get lunch and come back, and then really starting to look through the slices and how the machine would make it. But really it was a lot of material testing. There was a lot of updates to all sorts of resins, specifically wax-infused resin, that we had to basically burn out for the casting process eventually, and testing out what was working and adding little things to the machines. And it was basically, we realized that this is what we wanted to be doing for sure. But that being said, we also still have the goal to continue to try to claw back our way into architecture, where we're still in love with architecture, and we still are today. But the design scale and our focus has basically evolved over time since the beginning. So we went into product design and started getting larger into event space. We built this cool tree house in Santa Cruz and started doing restaurants and residential complexes. But we realized at that point that as we were getting bigger, we weren't doing that same digital fabrication that we wanted to as much. So we kind of like went back down scale and kept around the product design scale. And we're basically going to cover two scales here today of some of the projects we've been working on. So finding our niche, basically throughout all those different scales, it was exciting to realize that really design innovation for us was just through simplification. So as we did design research on material, geometry, technologies, and all sorts of different workflows and fabrication methods, we realized that if we can just take the simple aspects of them and apply them in correct ways, we can basically make product design for additive manufacturing pretty exciting and pretty fast. So the computational craftsmanship, which is basically the title of our presentation, is something that we like to hone on. Is basically like all those years and different ranges of fields that we've been in, and basically taking a little bit of each one and using those to our advantage to make our designs possible. We always look at software as something that is deliberately chosen, and the workflows we make help us basically create interesting outcomes, and we don't see it as something that defines our design language. It actually enhances it. So we introduced a sensory layer as well, which is basically what allows us to have a quick feedback loop once we start printing and touching stuff, and it allows us to make sure that our stuff's not detached from the reality that it inhabits. So our digital toolbox, which is basically what we are been building over the last 12 years, is something that we have our go-to softwares and kind of like we experiment with everything. And if you have new software you want us to try out, we'd love to try it. But mainly we like to focus with Rhino and Grasshopper and have our own workflow. We've played a lot with Maya and Fusion 360, recently a lot with NTOP as well. And basically these are the workflows that we find just as important as the design elements itself, is to allow to make really quick iterations and basically, like I said, shorten that feedback loop so we can get the products out faster, because we're not only just research, we make actual products for clients. So I'm going to cover large scale designs here. Basically furniture was something that we've recently been focusing on a lot, and this is all R&D, and so it's been exciting to kind of see what the technology has been at since we first started, like I said, 12 years ago. So recently we did what was called the carved bench with Eventscape. It was really exciting to basically start to use AI build for the first time to understand how a company that fabricates things in the architectural world works, and really understanding like the tool path and how we can simulate non-planar printing, as well as understand how we can kind of jump between tweens. And you can see there's a few layers here, and this is like some of the pinch points we have right now with the software. So this is where we kind of come in to kind of work with engineers or whoever's with the software to allow us to kind of like fix that. So this was the first prototype, and I wanted to show that one so that you can see the lines there. The other one recently we did was with One-Off Robotics. It was really exciting. They had a experimental material, and we thought, what if we take a really simple idea and design where you basically spin an object into a radial form, and can you print it radially? There's a fixed robot, but it has a table that basically twists out in a radial format to have that shape that you see here. This was exciting and challenging project for sure. And lastly, delicate density, which is a concrete table that we poured using FDM prints off of a standard printer. We wanted to see if we could make a standard printer create something that was 250 pounds and elegant. And so this was a lot of the in-house testing we've done before. Basically, we make ideas, we make them, we test them out ourselves. How does it pour? How does it unfold from the molds and stuff? And what is the hydrostatic pressure that's going to happen here? Where are the parts going to break, and how do we alleviate that? This type of stuff allows us to understand what we want to be doing once we start getting at the larger scale. So product design-wise, a few projects I want to cover here, and I'm going to pass it over to Arthur in a second here. So the mountain backs are these snowboarding high backs that we designed. This is with Aaron Portfield. We work with him a lot. He's amazing. He presented at the last conference. And this is with Stratasys and Henkel. This is basically a material study for a relatively cool project. This is a passion project for me. Arthur's about to get into his passion project. I was living in Colorado at the time. I was really inspired by the mountains. So using optimization for variable lattices and basically understanding what the border style of riding and using, like I said, different geometries to basically inform the structure was really exciting, and also lightweighting the high backs. And this is something that we do with all our designs, basically a layered design. So we establish some sort of, this is not always a process, but we establish some sort of form. We have, potentially some specific rider structure analysis that we want to have. So this was an aggressive rider for being within the backcountry, and then establishing a lattice that can basically be variable, and later on we added additional generative design of mountains. Mountain range basically adds a structure to it. So we're using cool and engineered software to create designs and things that aren't traditionally used this way. This is what's exciting to us. So I'll let Arthur take over from here.
All right, hi everyone. So this next project was a research project, an R&D project we did with NTOP, and trying to understand how to use NTOP for product design directly, and really understanding interoperability between Rhino, Grasshopper, and NTOP. The original one was we tried using topos in Grasshopper, but NTOP was way better. And so the idea is jumping between back and forth and doing topology optimization in NTOP and understanding how to take that back and inform the design itself, so that we can actually control the design and not just take the result of the software. So it's really understanding that back and forth and using all these different tools to what they're made for. So in this particular one, we really love the Boolean operation and gyroiding available in NTOP, and use that as a design feature for the casing, for the actual product itself, to give it this carved look, not without it being necessarily the typical gyroid you're used to look at. And we made a lot of variations on it. We were able to create the void and the fill of the gyroid to create biomaterial using MJF and using different colors, and as well as actually printing this marble texture on it, which was really cool to us, that you can actually have texture on the print. And it got tested by a bunch of people, and it works. You might recognize one of them. He might be in the room today. This next project, this one is a really interesting one. It's another collaboration with Aaron, and we worked on the midsole with Crystalon with Origin about 5 years ago. And I won't go too much into detail, seeing the time, but what was really great is meeting the team here from Variant that helped us basically finish the project last year. And using AI, we went back through the concept of the Roadrunner, the original concept, and were able to develop a lot of new textures and actually implement them into the upper design, and working with Variant, actually go through and doing the 3D knitting. And this is the pair that you see here on the side. And the really exciting project we want to introduce today, that we've been working on for the past few months, is a collaboration with Freeform Sports, and it's about athletic padding. So it's football thigh pads that we've been working on. printed with carbon. So we've been working with the carbon on this using their EPU 45. You can see the pads being worn right there. And I kind of want to take you through the process and how basically design informs a lot of the decisions we're making while we're still using lattice engineering to make sure the performance of the pad is there, and really mixing the two. So the lattice strategy, we've been working with the carbon team and the design engine and using their library to really be able to start guiding us into which lattice is going to be the most performative for this type of product and what's going to be the best for impact resistance. From there, really what was interesting is working with them is we're able to get actually the CSV out of the lattice so that we can control it directly and feed it back into our workflows in our system. So a lot of this is worked within Rhino and Grasshopper, and being able to extract that data, we're able to now, with that, as you can see in this picture, actually control where all the escape holes and drainage holes are going to start being implemented based on the lattice, and not just randomly. Basically, one thing that gets a little more complicated when you do these lattices is how to find where to put these escape holes to make sure that when the part is printed, the drainage is correct, and it helps with that. So that was really essential to get that, and then integrate it into our design workflow, making sure the skin of this pad is there. And then using kind of our homebrew meshing system out of Grasshopper, once this lattice is made, we're able to reduce just the overall size of the meshing. It remeshes everything and gives us those nice kind of like rounded edges a bit. And then using 3MF, since it's the sponsor of the conference, we're able to bring the file down because we're generating so many files actually through this project. It's been helping us to just reduce upload time and things like that. What's really great is this was tested at Ohio State's Injury Biomechanics Research Center, and it tests better than every pad on the market. So we're really happy about that. It tests better than the previous pad as well that we worked on. And what we're excited about is also, for the next phase, introducing simulation into our workflow. So before we even get physical testing, how can we simulate this digitally so that we can narrow down basically the right pads and then get those tested. And what's interesting you see here is we start introducing actually numbers and things on top of the pad, and that's where design really comes into play. And so what we've worked on is design automation. We're basically having to use different fonts. We have logos of all these different teams that we have to take into consideration, and this is where also a design eye is critical, because you have logos that are going to be way more complex. You got to make sure you respect the visual integrity of all these logos. You can't change them, and so when it comes to 3D printing, a lot of you might know that small details get really difficult. So where do you round the corners necessarily and things like that? And then working with different fonts. And then we, thanks to Dwan and the Scott Davidson and the Rhino team, were able to set up a 3MF exporter out of Grasshopper, so we can basically automate the export of about like 2,500 pads within 24 hours. So whenever we change something, we can just let it run and re-export basically everything at once, which is really great. I'm really happy about this and building that library. Very proud to say that all these people are wearing it now. It's NFL, NCAA, the 2024 Heisman candidate is sponsored by Freeform Sports and is wearing it. The feedback has been great. And yeah, I think I'll let you conclude.
Sure. Also, let's not forget that we got into the NFL, and Baker Mayfield, we just found out a couple weeks ago that he was wearing them, so it was really exciting because he was 2017 Heisman, and just in general, getting into the NFL was a little bit more challenging than the NCAA, but with all the NI deal recently happening, it's been exciting. So anyway, in conclusion, I hope the slide isn't too controversial, but basically we prefer design over computation. It is just a tool. We don't look at it as the main thing that we do. It is something that enhances our design. At the end of the day, the tactile form and function is really what's at our heart, and we hope you understand that that's kind of what we are. We are a design studio that just kind of uses fancy tools, and we like to use them in a way that is beneficial for the aesthetics and for obviously for the function. If you want to get in touch with us, just email us at info@slicelab.com. Thank you very much, everyone. Thanks, Juan.